Hello,
Wait a minute.
Dr. CP. Good afternoon.
Hello, good afternoon. So sorry. Wait a minute. Wait. Okay. So you will see behind me still so many people
I'm
because
sorry.
currently, yes, I have workshop, but it's okay. I will make tour.
You're so busy.
Okay, no problem.
Okay.
We have five presenter, right, Professor?
Yes, 5%ers. So what we're going to do today, I will wrap up a bit
Yes,
of contents of
maybe Professor Kitain can wrap up a bit and then continue by me, and then we can start by presentation for each group. How about
yes,
like that? Okay,
perfect, Dr. CT. Thank you so much.
you're
So
welcome.
let's wait for other students about 2 minutes. I think they
Yes,
are now starting to join. It's already 12:55 here in Japan, and I think
yes,
at
developing already.
10:55 in Indonesia, right?
10:55.
10:55. Okay, so let's wait for another 2 minutes before we start our class for today. So other students are still joining this Zoom meeting. So let's wait for about 2 minutes. Okay, so good afternoon once again to everybody from Kumamoto University and also to our ITS students and to Dr. City. I understand you're so busy now. Thank you for joining this class today. So this is what we are going to do today. I will wrap up a bit about the topics discussed in this class, maybe for about 4 to 5 minutes. And then we will have comments from Dr. City also. And then after that, we will have your presentation. You can just simply run the videos that you prepared. And then after running the video, we will start with group number 1. After running the video, we will ask questions to some of your classmates. So that's what we are going to do today. All right, so let me share to you my screen. This class is one good example of a combination of global team teaching and COIL. Global team teaching because we invited guest speakers from various parts of the world, like Southeast Asia, from the Philippines, Professor Aviso talk about environmental issues and optimization. From Petronas, or University of Technology Petronas of Malaysia, Professor Dr. Yusuf talk about biomass conversion technologies. And from Australia, we invited Professor Beltramini, who talked about the use of catalysts also for biomass conversion technologies. Professor Cosero from Spain talked about biorefinery and also bioeconomy. And also discuss the biomass scenario in Spain. Professor Satichai, although I put here process integration, he also covered process systems. It was really a very interesting topic we had last week, coinciding the Sakura Science program. And for today, we should not forget Professor Mahfoud from ITS and also Professor Uropon from Silpakorn University of Thailand also. And now we are coming to the end of this class. This is our 8th and final session for this class. Global Team Teaching plus COIL 2021. Thank you so much, Dr. Siti, once again, for making this happen. It's quite difficult to arrange this kind of global team teaching and a combination of COIL class. And I think it's also quite difficult for our students to connect, especially during this pandemic situation. Access to internet is also a problem, but I should thank our students for having with us throughout the course. Thank you so much, everybody. Well, in this class, we covered these various aspects. This is multidisciplinary class. We covered various aspects of biomass utilization. We started with the basic concepts of biomass utilization. From the talk of Professor Mahfoud, he also covered the biomass scenario in Indonesia. And also Professor Borapon covered basic concept of biomass utilization and also a little about the scenario in Thailand. Professor Avisa's lecture was quite heavy, I think, for our students, especially those who are not familiar with the life cycle assessment, the LCA. But you actively cooperated, even though I understand it is quite difficult for you. Some of the students gave up already after the second and the third meetings. But for you who are still here, again, thank you so much. And Professor Yusuf covered biomass conversion technologies, the raw materials that are available in Southeast Asia, especially in Malaysia. Then Professor Beltramini's lecture on the use of catalysis. Professor Cosero on biorefinery and bioeconomy, but also mentioning topics related to biomass utilization in Spain and comparing it with biomass utilization here in Southeast Asia. Professor Satichai's lecture was also too heavy. But, well, another problem was the connection. Okay, last week. But, well, it was really a very good lecture of Professor Satichai. We learned a lot from these invited guests, professors. And now, I'm wrapping it up. Well, we are doing this global team teaching and COIL with our Southeast Asian partner universities, especially ITS, because we would like to have this connection, collaboration with Japan and ASEAN. Although our focus here is on biomass utilization, it doesn't end the biomass utilization. We would like you to be aware of the possible technologies for biomass utilization. But it's not only that. You can actually apply this experience to some other aspects, not only on biomass utilization. And the good thing here is that we want you to be aware not only of the technologies, but the differences in cultures, mindsets of each country or various countries in Southeast Asia and Japan. While we develop technologies for our future society, we also want to develop human resources. And you will be the future leaders that will connect Japan and ASEAN. Japan doesn't have much biomass resources, as you all know. That's why in order to address this problem on climate change, carbon neutral society by 2050, they're not eyeing the use of Japan is not really keen on using biomass. They are into the use of fuel cells or hydrogen. But with this collaboration between Japan and ASEAN countries, we can develop the technologies, support the development of technologies for the utilization of the vast biomass resources in Southeast Asia. And we need to know the biomass scenario in Southeast Asia in order for Japan to develop those technologies, which I think very important. ASEAN countries should have a responsibility for Japan or Japan universities or researchers to know possible biomass feedstocks that are available in Southeast Asia, and whether the technologies we develop here in Japan are suitable to Southeast Asian countries. This is basically one of the many reasons why we have this COIL or global team teaching for our students. Now, I also would like to share this to you. This is remarks to the World Leaders Summit, COP26, Conference of the Parties 26. This is about UN, United Nations Climate Change Conference. That has just happened 2 weeks ago. It was ended November 12 in Glasgow, Scotland. And the UN Secretary General, Antonio Guterres, he is now the UN Secretary General in charge of this UN Climate Change Conference. He mentioned to the world leaders attending this COP, Conference of the Parties, that our addiction to fossil fuels is pushing humanity to the brink. What are those fossil fuels? You are already familiar with crude oil, right? We derive gasoline, diesel, and so on from crude oil. Crude oil is one example of fossil fuels. And we are addicted to the use of gasoline and diesel. And the use of these fossil-derived fuels is really harming our environment,
Recording in progress.
our atmosphere. And this contributes a lot to climate change or global warming. He also mentioned that we need to face this stark choice. Either we stop it. What is it? Either we stop it, this addiction to fossil fuels, or it stops us. It has reached a very alarming stage or level already. So we should act fast. We don't want this increase in temperature to reach 2 degrees centigrade above, this pre-climate change level. And even during this COP26, most of the nations already agreed to have an ambitious goal of not reaching a level of 1.5 degrees centigrade above the pre-industrial level. And our answer to this call of UN Secretary General Antonio Guterres is, of course, the use of biomass especially. This is one of the possible answers that we can have, to use the vast biomass potential of Southeast Asia. Not only Southeast Asia, but the Asian countries. We have, I think I mentioned to you that we have almost double the biomass potential of the United States or Europe. Even if you combine the biomass potential of Europe and the US, the Asia still has more than their combined biomass potential. And that's one possible solution to this. We should stop the use of fossil fuels by utilizing biomass, or if we don't do it now, this climate change will definitely stop us. So in final words, I would like to mention that, this is like a cliche. If the climate can change, so can we. All right. Let's change. Let's change for the betterment of the society. Let's change now in order to avert these climate change to happen. This is happening already, but we should stop it now, okay? So I hope that serves as a motivation for you, young generation students from Japan and also from Southeast Asian University. You will be the future of this society. Well, thank you so much for that. Well, that wrap up, okay? That wrap up the topics discussed in this class. Let's have some words from Dr. Siti. Dr. Siti, please.
Wait a minute. Okay. Thank you so much, Professor Kitain. Your writing this course is really touched me. And I'm sure our students from ITS and from Kumamoto University, because you are the future of our society. So I'm sure that you can change, as Professor Kitain said, if the climate can change, so we can be. So I'm sure that you can make the society, the environment better in the future. And then once again, thank you so much to students from Kumamoto University, from ITS, some of Silpakon University, Chulalongkorn University, UTP, etc., joining this COIL program. Before, it is not possible to have some class together like this. but due to the pandemic, we still have this possibility to connect each other easier than before. So I hope you can have many advantages currently compared to us before. So I hope you can, how to say, contribute more to our society. Maybe that's all because Professor Kitain already, how to say, talk so many things that it's really touched me that we have responsibility to our society. And a little bit, I just want to share about, not share, I just want to talk about that 5 group already submitted in time. I'm sorry. Wait a minute. Sorry, I will continue again. So already 5 groups submitted for ITS students submitted in my classroom, and Kumamoto University will submit to Moodle. And if I see the report and the presentation you submit, I really appreciate. For example, the group 1, there is the current practice of utilizing biomass from microalgae in Indonesia, its potential and challenge, because we know that how to say, Indonesia, we have a ocean is wider than our land, something like that.
Yeah.
And then the group 2 submitted about biomass for carbon neutralization that mentioned by Professor Kitain. If we addict to fossil fuel right now, so maybe it will stop us or something like that, right? And then group 3 submitted assessing environmental impact on biomass utilization. Group 4, the current practice of palm kernel shell utilization in Japan and Indonesia. And especially in the group 5, there is a student from Silpakon University who are actively joining in this final program. And the title in here is Comparison of Biomass Utilization in Japan and Indonesia. And I really appreciate it. You spend time to to work together and then submit it on time. So I will give again to Professor Kitain. Thank you so much.
Dr. Siti, thank you so much. I understand that you're so busy and yet you're here. And thank you for your comments. All right. And to our students for preparing the videos. I watched the videos. In my case, I received group number 2, group number 4, and group number 5. I'm still waiting for the videos and reports of group number 1 and number 3. Please, all right? Kumamoto University students, I still give you time. You have until today to submit the video, your presentation video, and the report, okay? So I will wait. I give you time. I understand that you are so busy today considering that it's your final examination week, but I can still accept your presentation video and report. Okay. So for now, let us listen to group number 1. Okay. You can run the video, show it to the class, so they will know what kind of video you prepared for us. All right. So let's now listen to group number 1 and a representative from group number 1. And before we start, by the way, we will prepare a certificate of participation to those actively participated in this class, especially those from our partner universities in Thailand, Malaysia, and the Philippines who joined this class even without getting any credits. All right. Okay. Group number 1, please, if you are ready, please share your video.
You can share it. I already opened for multiple participants. Please, group 1. Wait a minute. Let me check the member, Professor. I think group 1, I think most of them is go for Friday prayer. Maybe we can how to say, jump to group other group first.
All right. So shall we listen to group number 2, Dr. Siti? If group number 2 is ready, please run your video, please.
Yes. Please, group number 2, Imro'atus Nur Mufida, Dimyati Putri Renita, Nurul Fitria, Rahmadi Arno, Richard, Ninda, and Asahiro Daiki.
Let me share my screen first.
Sure.
Can you see my share screen right now?
Yes.
The recent report from the UN International Panel of Climate Change or IPCC enforced the urgency to meet the emission target set in the Paris Climate Accord from December 2015. Basically, the whole energy production needs to be brought to carbon neutrality by 2050. Sort and sink of CO2 emission needs to be in balance by then. The way to reduce emission and to pursue carbon neutrality is to offset emission made in one sector by reducing them somewhere else. This can be done through investment in renewable energy, energy efficiency, or other clean, low-carbon technology.
Biomass is material derived from living organisms, which includes plants, animals, and their byproducts such as garden waste, crops, and so on. Biomass can be used directly or indirectly as fuel. Charcoal briquettes, rice briquettes, crumble briquettes, and dried leaves are examples of biomass fuels that can be used directly as heating material or a power source. The use of biomass can make a significant contribution to waste management, fuel security, and climate change.
Now we talk about potential of bioenergy. Indonesia, according to the data, there are 10 biomass sources that can provide up to 33,000 megawatt electricity in Indonesia. But unfortunately, there are just 1% that are utilized to electricity now. Biomass utilization in Indonesia can be converted to biogas or turned into electricity with coal co-firing technology. And about the regulation, Indonesia strategy and vision about biomass is very positive. We know that in 2025, 10% of energy portion is from biomass.
So now I will talk about the potential of biomass energy in Japan. Since Japan is surrounded by rural area and forest, there is not much differences in the condition of cyanide wood, which can be obtained in each region, so it has the potential to make it easier to spread locally production and locally consumed electricity, in which each region generates its own power. Furthermore, in Japan has a lot of small and middle-sized companies, so it can be created a cycle of supply and demand based on biomass, and employment will be generated, which can be expected to rise the level of the economy. In addition, there is the potential to accelerate test operations and lead to practical applications by having many research institutes and universities in close connect with local companies.
In short, Japan and Indonesia are at a completely opposite position in terms of biomass potential and utilization. Japan's technologies and infrastructures for biomass utilization are readily available but lacking in the availability of domestic biomass feedstock and reliant on imported biomass to operate, whereas Indonesia's huge biomass availability and potential are not fully utilized due to the lack of local technologies and infrastructure. This opens up an opportunity for the two countries to collaborate and benefit each other in terms of bioenergy development.
The collaboration that mentioned before is needed to support the carbon neutrality program because it's all wet wind, so the production needs to be on large scale to meet the demand of bioenergy.
Wow.
Yeah, that's our video of final report presentation from Group 2. Thank you.
Amazing video. If you can, there like I there are like tears flowing. Really, it's really an amazing video. Thank you. Well, I'm becoming emotional now.
It's like what you want, Professor, right?
Right.
So Japan mature already in technology, and then especially Indonesia, we have abundance of biomass. So if we can collaborate, so we sure.
So we can collaborate, everybody. Well, I'm becoming emotional. I'm really impressed with the quality of the video and the contents. Thank you very much, group number 2.
Thank you for the compliment, Professor.
Really, indeed, yeah. I'm really impressed. So anybody who would like to ask questions to group number 2, please. Questions? Anybody?
Please, if there is questions or comment from other groups to group 2.
Dr. City, maybe not now. We watch all the videos and then we ask questions later. All right. Dr. City, would you like to introduce group number 3, please? Yeah.
Okay. The group number 3, there will be Teguh Sukindra, Tetuko Mudi, Toaji Karto Dirjo, Vira Rizky Ramadan, Mutia Dinda, Ihsan Habibur Rahman, and then 2 students from Kumamoto University, Sauta Sakamoto and Risa Fukuda. Please, you can share your video to us. Please, who will share? Dinda, maybe Viva, yes, Isa or Sulta, maybe you can share.
Excuse me, sir.
Yes.
I'm sorry, the video is in Tetuko, but the Tetuko has a trouble in connection.
All right.
Yeah.
Dr. City, do you have?
I will share to Dinda. I will share to Dinda. Maybe we can go to another group first.
Okay.
While I'm share to Dinda, so she can share later on. Maybe we can go to group 4.
Group number 4.
Ami Matsukubo from Kumamoto University, and then the rest from IPS, Rafida, Talita, Nur Sofia, Diva Latifa, and Sang Aji. The video is the current practice of palm kernel shell utilization in Japan and Indonesia. Please
allow me to share the screen first.
Sure.
Is the sound audible or
It's not audible. Can you share the sound also, please?
from the settings? This has already shared the sound. I don't know if it is audible yet.
We couldn't hear the audio.
Oh, sorry. Wait, I think there's something in the atmosphere. Sorry, is it still not audible?
Still not audible. Yes.
Probably for the other group mates, can you help share the video? I think there's something wrong with my room share.
I try to share.
Oh yes, please. But Kubo-san, it's not playing.
I'm sorry, I don't know how to share audio.
All right.
Please excuse me, this is myself. Maybe I can help you. Please stop sharing first. Stop sharing. So now reshare. When you are about to share the screen, you check your left to right down. There should be share sound at the down. You need to click that one first. When you are about to share your screen.
Okay, I tried.
Yeah, try to share the screen and you check the down left. There should be something like share sound. Did you click the share sound first? You need to click the share sound before you share.
Okay, good afternoon, sir, ma'am, and also.
Good. It's working now.
Okay,
Good.
thank you.
Perfect. All right. Go ahead, please.
Okay, good afternoon, sir, ma'am, and also all of the participants in this Zoom meeting. We are group 4. We will presenting our presentation about the current practice of palm kernel shells utilization in Japan and Indonesia. Next. Okay, palm kernel shells are a biomass waste generated by palm oil mills and are generating very good traction as a renewable energy source in Japan. There are a few specifications before PKS can be exported to Japan. First is moisture content, the second is calorific value, and the third is impurities and contaminants. Japan usually buys with a volume of 10,000 tons per shipment. The location of PKS stockpile that is closest to the seaport is the ideal condition to facilitate transportation of shipment. Next.
Then we can see the comparison of palm kernel residue data between exporters and Japan. We can see that the trend is going up and is growing exponentially in Japan, where now it has reached approximately 5 million metric tons by 2025. So there are a few challenges, one of which is that Japan lacks the steady biomass supply, therefore they have to import. But we can see that the price of PKS is the cheapest, which is 21 to 24 yen.
Only challenge is how to ensure the stable supply and demand of biomass in the long term. Only small portion of PKS is certified to be sustainable, so the introduction of sterling requirements by the Japanese government will severely limit supply. Next. Now we move on palm kernel shells potential in Japan. From 2023 onward, a significant uptick in demand is expected. A lot of the Japanese projects have circulating fluidized bell boilers. This is the image of it. And imports have exceeded 1.4 million metric tons in 2019 in Japan. Next.
Okay, next, in Indonesia, Indonesia can actually utilize this biomass as a source of bioenergy power plants. But in this country, the program for developing environmentally friendly energy through palm kernel cells biomass is neglected with minimal incentive. Next, in this graphic, we can see that the demand from palm kernel cell has unexpectedly occurred especially in Malaysia and in Indonesia, because the moisture content material in the palm kernel shell is lower than biomass residue from exclusive source. So it's not surprisingly that palm shell are extensively used and opportunity fuel. Next.
The challenges in Indonesia. Although the potential and benefits of palm shells biomass are very large, the government of Indonesia hasn't given special attention and provided incentives to be used as a source of bioenergy power plants. Next.
Discuss about the potential in Indonesia. It can be seen from the graph that the production of CPO is increasing every year, so that the production of palm kernel shell also increase. Next.
Next, this is the where we get our sources from. And that is all from us. Thank you everyone for listening and have a great day. Thank you.
Thank you so much, group number 4, all right, regarding the utilization of palm residues, including palm kernel shells. That's really a very interesting video. We're also working on the utilization of palm residues. We have published many papers related to the utilization of palm kernel shell, for example. So you may also want to, if you are interested, you may also want to have a look of those publications. All right. Good.
Thank
Dr.
you so
Kitty.
much. Yes, thank you so much. Thank you so much. I'm so happy you can work together.
Yes, yes.
Okay, we will go to group 3. How about group 3? Yes, Dinda.
Okay, I'll try to share screen the video.
It's also not audible.
Yes. Dinda cannot hear the voice.
Yeah.
I'm sorry.
Can you share the the audio also, please.
How to show the audio?
Marcel, maybe you can share to Jinda how to turn on the audio so everyone can hear the voice from the video.
All right. Linda, maybe you can stop sharing first. Stop sharing. So now try to reshare it. But when you want to share it, check the down left. So you see enable or share audio. You need to click that one first before you share. Did you get it? Let's see.
Today we're going to talk about environmental impact of biomass utilization. Next slide.
Introduction. Compared with conventional fossil fuels, bioenergy has distinctive advantages due to its renewability and large quantity, and thus plays an essential role in helping to preserve environmental sustainability. Industrials and utilize has potential to convert biomass to heat, electricity, and transportation fossils. We must examine whether the resource is abundant, efficient, and environmentally sustainable.
Okay, as for the air pollutions, it emits particulate matters such as nitrogen oxides, monoxide, sulfur dioxide, and other hazardous air pollutants. And the only way to reduce is to control by combustion modifications and using selective catalytic and non-catalytic reductions. Next slide.
Next is the water quality. Bioenergy production can affect water quality through physical, chemical, biological, as well as thermal pollution loading. Direct impacts on water quality arise from pollution through intensive agricultural production using fertilizers and different types of pesticides, and other malpractices in agriculture such as tillage of unsuitable soil. Pesticides can have a profound effect on aquatic life and water quality, as pesticide residues are carried to ponds, rivers, and lakes by surface runoff or spray drift. They can cause acute poisoning and also chronic poisoning to aquatic animals.
And then the deforestation. Deforestation
I'm sorry, sir. I think I have connection trouble, so the video is paused.
How about another member, Dinda? Maybe they can help you.
Ibu?
Yes.
Yeah, I think
You can help.
I think Dida is having trouble with the internet. So
Mm.
yeah.
What do you think, Professor? We goes to group 5 while group 3 fix their problem. So, okay, maybe, yes, okay. So maybe we can go to group 5. There is Fikri, Elena, Anissa, Marcel from ITS, and 3 students from Kumamoto, Kuhei, Ikuri, and Sumire, and 1 from Silpakon University, Pirawat, Wong Surakul. So please, you can share it.
Okay. I will share the screen.
Oh, thank you, Ikuri.
Hello everyone, we are from Group 5 and today we'll talk about the comparison of biomass utilization between Indonesia and Japan. The first one will talk about the introduction. Biomass utilization is the focus of current research. Why? Because biomass is fully a new resource that is environmentally friendly and easier to extract. Indonesia and Japan are two countries that have very large populations, with the population continuing to increase. Energy needs are also growing. Indonesia and Japan have partnerships in biomass power plants based on palm kernel shell.
In 2030, Japan predicted that the ratio of renewable energy is about 22% to 24%. Of this, biomass is expected to account for 3.7% to 4.6%. Then, two-thirds of Japanese land is forest, and there are many trees which is more than 50 years old, so what are the potential? However, we need to take considering forest calculation system to sustain our forest in the future. In addition, financially independence and the maintenance of sustainability is necessary for Japanese biomass.
Next, we talk about Indonesian situation. As an agricultural country, the energy potential from biomass research in Indonesia is relatively abundant. The amount of solid biomass waste potential in Indonesia is about 49,000 megawatts.
All sources of biomass, food as a biomass which has long been known by the public. Food as biomass is renewable fuel. An estimated Indonesia produced 470 gigajoules per year.
Next, we will talk about the challenges of biomass utilization in Indonesia, especially expensive compared to the hydropower and the geothermal because of especially of technology, high cost because the biomass are spread all over around the country. Because we know that Indonesia is consist of many islands. For the last one, we'll talk about the seasonal. We know that Indonesia is consists of only 2 seasons. Next, we will talk about the comparison between Indonesia and Japan. So this comparison we classify into 3 categories: to the cost, potential, and issue. For the cost, the Japan is using FIT system, and Indonesia hydropower and geothermal are relatively cheaper than biomass. Talking about the potential in Japan, power and wood, Indonesia the various resources. For the issue, Japan is financial independent and forest situation. For Indonesia is technology and cost.
In the conclusion part, Japan and Indonesia are both lead in the biomass. However, they are still facing many difficulties to convert this biomass into the energy. Thank you for your kind attention.
Thank you so much. You even make a background for the Zoom meeting. Oh,
Right.
it's amazing.
Thank you so much, group number 5, and for the collaboration. Yeah. This is actually the essence of this COIL program, collaboration. Okay. And the contents of your videos. Amazing. All right. Thank you. Thank you so much, group number 5. Dr. Siti?
Yes. How about group number 3 or number 1?
Yes, I'm from number 1.
Oh, please. Yes, please. So group number 1, Rosid Adani Atta, Brilliant Fairuz Iza Ramadan, Ismail Mashhab, Ahmad Rifki, and Ahmad Habib from ITS, and one from Kumamoto University, Matsusita Natsumi. And then the presentation is about the current practice of utilizing biomass from microalgae in Indonesia, its potential and challenges. So please, Matsusita Natsumi.
Good morning, everyone. We would like to present to you about our final tracks. It's about the current practice of utilizing biomass from microalgae in Indonesia and its potential and challenges. We presented as group 1. Next. The first is the introduction. Development of alternative renewable fuel source continues to be carried out in order to answer the major temporary and future challenge faced by mankind on Earth, namely the availability of fuel energy.
Okay, next, fact about microalgae. Microalgae are renewable, sustainable, and economical source of vehicles and food ingredients. Next. Okay, here's the picture about potential application of microalgae into biomass. Next.
Application of microalgae into biomass. The most challenging and crucial issue are accessing microalgae growth rate and product synthesis, the weathering algae culture for biomass production, retaining biomass, and optimization the fermentation process in case of algae bioethanol production. Next. Next, utilization practice as biomass. The process of making microalgae is not too difficult. The first step in identification and isolation of microalgae. That process is filter, drying, and extraction. Last, purification and extraction to break down fat into hydrocarbon. Next.
Okay, so there are about data about microalgae. Is microalgae have lipid like chlorella sp, Caesarium sp, Nanochloropis sp, and Botricoccus brownie. And then we have a microalgae like have a carbohydrate and protein like a Coperidium cruentum, Brimnesium parvum, Spirogyra sp, and Gunalia salina. Then we have some picture or figure about the microalgae like this. Okay, and then next.
In table 1, it can be seen that microalgae have a light oil yield with little light requirement. Next. In table 2, it can be seen that there are several variations in oil content for various types of microalgae.
Finally, I would like to state our conclusion. First, microalgae is a renewable energy source that can substitute some fossil energy because it has a lot of oil content and does not require a large area of land for its production. Second,
The most challenging and crucial issues are enhancing microalgae growth rate and product synthesis, dewateering algae culture for biomass production, creating biomass, and optimizing the fermentation process in case of algae bioethanol production. That's all. Thank you.
Thank you.
Okay, thank you so much. As your information, together ITS, Kumamoto, and Chulalongkorn, we have, right, Professor, one project about utilization of microalgae. And especially in our lab, we also have done many works on microalgae. The current we also use pyrolysis combined with microwave, etc., something like that. Okay. So thank you so much.
Group number 5, thank you for introducing the use of microalgae for, well, in your case, you mentioned about algal bioethanol. You can, yes, you are right. We can do fermentation in order to convert algae, microalgae into useful chemicals like ethanol, bioethanol. And as you all know, we can use ethanol also as a fuel, as an additive to gasoline. Okay. And there are a lot more in microalgae. You can, of course, I introduced already to my students here in Kumamoto University that you can also produce health products, not only energy, health products from microalgae. And Euglena, a startup company here in Japan, is utilizing Euglena, which is microalgae, in order to produce those products. And later on, they are also going to develop, they are actually developing already biojet fuel from microalgae from Euglena. So there are so many future prospects on the use of microalgae, not only for bioenergy production, but also for biochemical production. Okay, very nice presentation, group number 5.
Yes, we still have one group left in here, group number 3, right?
Right.
So
Not group number 5. I'm sorry, group number 1, right? That was group number 1. I'm sorry. Okay.
How about Dinda?
Excuse me, Vira Ramadan want to share, but she's not in the Zoom because in the waiting list maybe.
Oh, waiting.
Right.
No? No one in the waiting room, right? Group number 3, Teguh, Tetuko, Vira, Mutia, Ihsan, Sausa, and Risa. Dinda, maybe you can ask help your friend from Kumamoto University, or maybe ask Vira to join in soon, something like that.
Ibu? Hello. Ibu?
Yes, Marcel?
Is it okay if I have Linda? Is it okay if I...
Yes.
Professor Marcel will help to share the video.
Yes.
Okay.
Please, Marcel, thank you.
Okay. Please, Marcel.
Today we're going to talk about environmental impact of biomass utilization. Next slide.
Introduction. Compared with conventional fossil fuels, bioenergy has a distinctive advantages due to its renewability and large quantity, and thus plays an essential role in helping to preserve environmental sustainability. Industrials and utilize has potential to convert biomass to heat, electricity, and transportation fossils. We must examine whether the resource is abundant, efficient, and environmentally sustainable.
Okay, as for the air pollutions, it emits particulate matters such as nitrogen oxides, monoxide, sulfur dioxide, and other hazardous air pollutants. And the only way to reduce is to control by combustion modifications and using selective catalytic and non-catalytic reductions. Next slide.
Next is the water quality. Bioenergy production can affect water quality through physical, chemical, biological, as well as thermal pollution loading. Direct impacts on water quality arise from pollution through intensive agricultural production using fertilizers and different types of pesticides, and other malpractices in agriculture such as tillage of unsuitable soil. Pesticides can have a profound effect on aquatic life and water quality, as pesticide residues are carried to ponds, rivers, and lakes by surface runoff or spray drift. They can cause acute poisoning and also chronic poisoning to aquatic animals.
And then the deforestation. Deforestation of forest clearance is the removal of a forest or stand of trees from land that is then converted to non-forest use. Deforestation can involve conversion of forest land to farm, ranch, or urban use. Deforestation can cause some impact on environmental, especially impact the atmosphere, hydrological, soil, and biodiversity. Next.
And then from three negative impacts that I have mentioned before, biomass, of course, have positive impacts too. For the first, contribution of renewable energy. In total, primary energy consumption in world is about 19%, and for biomass only contributes about 30%. And then for number two is reduce greenhouse emissions. Even though biomass utilization contributes to produce of carbon dioxide, methane is 25 times more potent than carbon dioxide. Biomass power plants efficiently combust the methane, emitting carbon only in the form of carbon dioxide. Biomass can produce less emission in the range of 14% to 90% compared to emission from fossil for electricity generation. Okay, next slide.
Conclusion: the main requirements for using biomass in a sustainable manner and in environmentally appropriate ways are an intelligent management of all aspects of development and effective institutional communication and cooperation. Environmental considerations can be handled wisely if good information is compiled and well used, and if decisions are made within a collaborative extent. Thank you for your attention.
Thank you so much for group number 3 and also Marcel. Professor, actually, I have one video.
All right.
It's yes, it's talking about the utilization of a biomass also, especially from agriculture waste, because we have it's last week we have community services and something like real work. So we send 14 students to the village to help people in there to make for cattle feed, something like that. Okay, please,
Dr.
Marcel.
CT, yeah,
Yes.
please share it to the class. I think
Yes.
it's a very interesting video.
Yes.
Please. All right.
Please, Marcel, please help me to share.
Please, the video haven't reached me yet.
Oh, I sent it to lab already before, or maybe I have to send again.
Oh, wait 1 minute, let me check it.
Yes. If not,
Oh, all right, on YouTube. Okay.
Found it?
Yeah, 1 minute. Sir.
Okay.
1 minute. I need to open it first. Okay. I mean, it is loading. 1 minute. All right. Wait 1 minute. To play this one first.
Okay, thank you so much.
Dr.
So,
Sita, I saw you. I
yes.
saw you in the video.
Yes,
That's what they call
yes.
community engagement, right?
Yes,
That's
yes,
all
yes.
about biomass utilization, and we also need it here in Japan. Although we're talking here of biomass utilization, it also engage with the community, the local community, and that's one very good example, Dr. Siti. Thank you so much for sharing the video. Right.
I'm 14 student, stay in the village more than 1 month.
1 month?
More than 1 month.
Wow. In the village, right?
Yes, in the village. So starting, they collect the rice straw and then corn husk. After that, they grinding to become, how to say, to size reduction.
Size reduction,
Yes,
and then
yes.
you
We use
make
grinding.
pellets. You
Yes,
make pellets out of those rice husks.
Mm.
Right, I see.
And
That's
then we
very-
ferment it. After 1 week fermentation, we feed to the cattle, something like that. And then we measure also how much weight increase per day. So more than 1 kilo per day. More than 1 kilo. Almost 2 kilo per day. Yes, the cattle increase, the weight increase per day 2 kilo. So that's why hopefully the first can minimize the price of the, how to say that one, for the feed, and then we can utilize the biomass that abundant in there.
Mm-hmm.
And the second, they can have like income because they will get margin by because in Indonesia, if you sold a coal, something like that, it's depend on the weight. So if you get profit, for example, the price of 1 kilo of living coal is about 50,000 rupiah.
Okay.
So if one day can increase 2 kilo, so you will have how to say, from the cell, something like that is around 100,000. And then just minus with the price of the feed, something like that. So for coal, you need 3% of the weight of the coal. So if the weight of the coal is about 300 kilograms, so you need almost 10 kilograms. And then in the market, usually the price is more than 2,500 rupiah. So you have to spend money almost 50,000 per day, something like that. So you still have difference about 50,000. So that's as a profit for one cow, for one day.
I see.
Yes.
All right. Wow. Yeah. Again, I think that's a very good project, Dr. Siti. And to our students, if you can also do the same in order to help the community engage whatever you learn probably in this class, to be able to engage to the community. That would be a very good results of this biomass utilization class. Again, Dr. Siti, thank you so much for sharing that video. All right. Well, we still have 15 minutes. And if we have questions from our students regarding the videos that each group shared to the class, please, if you have any questions. No questions.
Because
no questions. Maybe they are, well, they learn a lot already. They understand the how to utilize biomass already. Well, anyway, if you don't have any questions, we already shared our comments to each presentation video that you shared in class. So let us close this class, all right? And maybe we can ask Dr. Siti first, if it is okay with Dr. Siti, to have your final comment for this class, please.
I think I already put comment on the project here, but not shared yet.
All right.
Yes. How about we have a photo session together, Professor?
Oh, yes.
Because we end this class. Please.
If it is okay to everybody, please, yeah. Okay.
Please, yes, Elena, Matsuhita, you can turn on your video so I can see you more.
All right.
Oh.
Okay.
Okay, Richard, good. Piawan, Pirawat, Ninda, Lira, Matsuhita, Ikuri, Marcel, Ami. Okay.
All right.
Hi.
It's okay also to our Kumamoto University students, if you would like to share, I mean, your face. Right. You would like to open the video, please. Okay. All right.
Okay.
Good.
Who take picture, Professor?
Yeah.
Who will take picture?
All right. Good. Okay.
Okay.
Yes.
No need to count down.
All right. Okay.
Mm.
So everybody,
Smile.
3, 2, 1.
Okay, thank you.
Good. Okay. So, all right. So let me save it first. Well, this comes to an end, this class, and I hope you learn something. You learn something from this class, from various prominent researchers and professors all over the world, not only from them, but also from us, Dr. Siti and I. Not only from us, but also from your classmates. Okay. I always tell to my students that you don't only learn from us, your teacher, your professors, but most especially you also learn from your peer or from your classmates. And from the videos you presented, I think you learn a lot from those videos. Amazing, interesting videos. So, okay, that's it from me. Let me close this class. And thank you very much once again to all of you, students of Kumamoto University, student of ITS, students of Silpakorn University, Chulalongkorn University, University of Technology Petronas, and also us probably in 1 or 2 sessions, students also from De La Salle University in the Philippines also participated in 1 or 2 sessions. So thank you so much. And thank you for being with us until this end. You didn't give up. So thank you so much. All right. So that's it. So I hope to see you again in some other occasions, hopefully face to face next time. All right. So bye-bye, everybody. Thank you so much.
Bye-bye.
Bye-bye.
Recording stopped.